Yeah, this time I asked my coworker to take a record because
Oh, good.
I always
Okay.
so like for
Yeah.
my first presentation will miss the first 10 minutes.
Oh, no.
Oh no, I haven't. What's going on?
Me.
Actually, maybe
Yeah.
because we only need
Yeah.
a right.
So Lou, to answer that question, what I would say for that is they could put their sample in at normal temperature and then ramp it up, and then change the temperature up to 70, and it'll melt at that. So the highest range is 70 C.
Okay.
And then that way, if they wanted to even watch the RI change, they could do a continuous watch, and then they can continue to. So they can.
I forgot what the highest is.
So it's from 10 to 70 Celsius. So that would be right there, but we would be able to hit it.
Okay.
So they can put it in at room temperature or wherever they would like, and then change the temperature, and then it will heat. So this entire metal ring is Peltier, so it's temperature controlled. So that would melt the sample.
Okay.
And then if needed, they would be able to.
Well, we cannot set up the temperature from here.
I don't know, so I'm trying to figure that one out right
Shall
now.
we restart or something?
Yes, I think we should. So I'm gonna.
So I need to log in, right? Okay. It's enough. Show start. So you see, it's not like me. So in this way, I will be the one who fulfill that manifest. And
I'm gonna come back to this. I don't know what's going on. So.
maybe we don't need the call keys window that big.
Oh, okay, good. Okay, good. I don't know what it was.
So for different mode, it will allow you to change different things? Is that
possibly it could be that specific table was measured only at a specific temperature, so then it's set to that temperature maybe.
Okay.
And so it.
Okay.
Okay.
Whew. Okay. So let's see. We're gonna start. And now.
Yeah.
Shall we start now? Okay. Yeah, we have professional.
Yeah.
Okay, good.
All right.
Yeah.
Do you want to go ahead?
Okay. Yeah, go ahead.
Hi, my name is Shelby Voorhees. I am the product specialist for Anton-Paar for the instrument we'll be seeing today. I'm based in our central regional office in our Chicago territory, and I cover our central region. So today we're going to be going over two different instrument setups. We have our ABBEMAT Multi-Wave here, and then we also have our MCP 5500. And everything good? So
Yeah, so far so good.
So we're going to go over just some of the basic setups and then go through general functionalities. Both of them are fairly simple instruments to use for the most part. Both of them are pretty much you put your sample on and you can get a reading right away. We're hoping to have our sample cells here for the MCP. Unfortunately, they were supposed to get here by 8 o'clock this morning, but due to some delivering issues, possibly with weather, we're not able to get those here in time for for this meeting and for video chat. So we'll make sure that we send some kind of follow-up instruction on how to use those properly as well when I'm able to. I may take a video of myself in my own lab showing filling. For the most part, though, that is a pretty easy application to do, and you should be able to figure that out as well. It's fairly simple. So we'll go over the general usabilities of both instruments and then go through that part of training as well, and then go into more detail at a later date. So I think we will go ahead and start on the ABBEMAT Multi-Wave if you'd like. Do you want to transition the camera here so we can see the screen maybe? Here we go. Okay.
Oh, you know what? Just now I tested in this way. I think it works pretty well. So, and bending down.
All right, great. So the ABBEMAT Multi-Wave is in two sets. So we have our actual measuring module here, and that is connected to a power supply and then is connected to our computer. And the computer will actually be where we see our measurement data come from and where we'll be able to use all the functionalities of the instrument. So here we have the instrument, and here is the software as well. Let's see a little bit.
Yeah, that's fine. We will share the monitor later, so you should not.
Okay, that's right. Yep.
Yeah.
You'll see. We'll get back to the menu of the instrument in just a little bit. So here we have the module. This is the entire thing. Oh, sorry, I moved it. You got it to where I needed it.
Yeah,
so for the most part, if you've used a digital refractometer in the past, it's a fairly similar process. We have just a little lid here that keeps light from getting in. Right now I have a little bit of water in there, so I'm just going to pull that off with a Kim wipe. And I'm actually going to take some ethanol as well and just dry that. And this is something you normally wouldn't leave sample on the prism of the cell, but I did just now, so just get that over. Okay, so for normal sample measurement, our temperature range is between 10 degrees Celsius to 70 degrees Celsius. It is controlled via Peltier temperature control here in the prism. That in all of this metal portion is connected to temperature control. And then we have our synthetic sapphire here at the bottom, which is where the sample will actually be. And if you can kind of see, it's a pretty small, shallow fill, and it really does not need very much sample to measure. For the most part, you want to be able to cover the bottom of that prism and then a little bit more. If for some reason you didn't have enough sample in here, the instrument will give you a little brief warning that's saying, hey, there's not enough sample in here, fill a little bit more. For the most part, I would say max would be like 2 milliliters for needed sample measurement, probably a lot less than that. Not even sure if you could fit a full 2 milliliters here. And that's pretty much that. This can get very hot if you have put the temperature up very high. So do be careful when coming in to clean with a Kim wipe or something to be aware of what the current temperature is. On the menu, you will be able to see your set temperature versus the actual current temperature. Let's see, do we have a question?
No.
Okay. And this instrument also is, of course, a multi-wavelength instrument. The general, most commonly used wavelength is 589 nanometers. And then this one, let me see, we also have available 485, 546, and 655. So those are all available, and those you can change back and forth your wavelengths with just the click of a button. So you can go from 589 and then select it and go to one of the other ones with just clicking and changing. And the instrument it takes half a second for the instrument to switch through the interference filters to change wavelengths. So overall, that's pretty simple. In the back here, you can kind of see a little bit of what's going on. We have the module here connected up to a power supply, which is then connected up via RS-232 cables to the PC to communicate that way. And we're just plugged into a normal 115-volt power supply in the wall. So I think, and then this lid here, it has this little notch, and if you can push it down, let me see. This is the fully closed position here. So to open it, you just pull this guy up, and that's it. And you can kind of push him down. I usually am more careful than I need to be. It kind of has a little bit of a clip there, and you do want to put a little bit of force on it, or else it won't open. So it's okay to use a little bit of force with that. Both Lou and I were being very cautious with it, but then it wants you to kind of push a little bit. So that's how we do that. Do we have any questions so far on the physical parts of the instrument before we move on to looking at menu structure and the capabilities and the built-in tables that we have for the multi-wave? Feel free to type a message if you have any questions into our chat window. We're keeping an eye on that. If not, I'll go ahead and move on. So I think Lou is going to share the screen so that you can see the, let's see our menu. Okay, great. So I think you guys should be able to see this now. So it's a little bit of an older software, as you can see. It is on our desktop. There is a tab that says ABBEMAT PC. You would just double click that and it will open up. And we do have user profiles on there. I believe Lou is currently the administrator, and I believe we will all be making sure that there are some general profiles created, as well as if there need to be specific user profiles, we can make sure that those are created as well so that everyone will be able to log in. For the most part, this is the main part of our screen. You can see the main measuring sample output here. That's what we're looking at, our current wavelengths, our current actual temperature, and our set value temperature. There are different modes of measuring, and we'll go through that a little bit later. Of course, we have our current time, date, user, and time here. So I'm going to go ahead and move right here to menu and just kind of go through the options that we have. So temperature setting, that is pretty straightforward. It is as you need to control the temperature. This is where you would input that number. Again, our temperature range is between 10 and 70 Celsius. If for some reason you have a specific sample, sometimes there are specific samples that have a method which require ambient temperature. You can turn off the temperature control of the instrument as needed for those samples, or a lot of people will just go with 20C or 25C. So if ever needed, you can do that there as well. So I'm just going to leave it at 20 Celsius for the moment and go to our next place here on our menu, which is wavelength. So again, this is what I mentioned. You all have, these are all the wavelengths you have available: 485, 546, 589, and 655. And you can just toggle between them like that. It takes about a second for the instrument to change over. In fact, if you're standing here, you can very slightly hear it shifting interference filters. It's a very quiet thing, but if you take a moment to listen, you can hear it go by. After wavelengths, on our menu, we have what is called scales. So these are all currently built-in concentration tables or other different types of refractometer calculations, which are built into the system already. As needed, you can also create new functions or tables or whatever is needed pretty easily. You can just come in here to new, name it, and then go through the steps of that. Or if for some reason you needed to edit any of these, you can do that as well. Right now we're just on regular refractive index. However, this is kind of everything we have. Kind of goes down a list of fairly broad industry needs. And then you could just, for example, I'll go through and I'll click bricks, which is a sugar table. And now the whole instrument is set to the bricks. I'll go back to just RI for the moment. There we go. After scale, we have measuring mode. So the instrument, as is many Anton-Paar instruments do, if we're able to get a current live reading, we do that. And so that is sort of what that continuous is. So if you're on continuous, which is the automatically displayed method, you can put your sample on, and as you saw earlier, possibly with when I was I had water in the cell, it displayed my current live RI for that water sample. And if I wanted to save that data point, I would just hit record right here. So that's pretty easy. Right now we are saving all of the data from here. You're able to actually print to a physical printer directly from the ABBEMAT PC software. I think there's another place, I'll go to that in a second, and you can see that those are already preloaded in, and if you need to just save it as a PDF file or anything else, just directly to the desktop, you can do that as well. So again, back to where I was with measuring mode. If you hit record during that live reading, it'll save that data point. So going back to measuring mode, I'll go through with these other ones a little bit. Some of them are fairly straightforward, start and stop manual. That is something where you can start a measurement and then stop it on your own, pretty much like that. Start and stop automatic is something that you can set it when it stabilizes, it will then stop the reading. Start and stop constant reading, I believe that one functions similarly to a scan as needed. And then continuous averaging, I believe it will take your measurements there and then average them together and then give you all of those readings as well as the average value. I'm going to leave it on continuous right now. Recording, I'm just going to skip over that one as needed, and I'm going to go forward to adjustments. So the instrument comes with a factory adjustment built into it already. If ever needed that you, for some reason, perform some adjustments and you're looking back at your data and you're looking back at your new measurements and you think to yourself, hey, I think something went wrong during that last adjustment. I need to reset back to factory and kind of just start over. You can do that right here. So be a little bit cautious when restoring back to factory. Only do it if you absolutely need to, but it is an option if for some reason you ran some adjustments and maybe the cell was contaminated with sample as you put the standard on or something like that. And so I would just be cautious with that, but if ever needed, you can restore back to the factory adjustment. So there are, besides factory, which is pre-installed, there is the 1-point adjustment and the 2-point adjustment. 1 point, we usually do that with just a water standard, and that I would recommend to actually getting a water refractometer standard so that you're not just taking your DI water in your lab and putting in the average RI for that water. You can do that, however, I would do that with a grain of salt and realize that water that you're looking at may not be perfectly pure, nor has it been analyzed and measured by a third party. So I would just, be cautious with that, and I do recommend using refractometer standards. For the 2-point adjustment, which is a little bit of a broader range, if you wanted to make sure that the specific range that you're looking at is very tight, your 2-point, you could have one at a lower RI and a higher RI. You can use a water refractometer standard, or you can use bromonaphthalene or any of the other ones that are commonly out there. And then again, I would recommend using actual RI standards for that. And for the most part, it's very easy to do. Again, as is with most digital refractometers, the measurement is very fast. It'll give you a live reading right away. The only thing probably what I would say that would take time is temperature adjustment and stability, just so that we want that temperature to stabilize as well as possible. So that is probably, it's going to take the most time of anything that you do with this instrument. And I would say that also applies to the MCP as well, the polarimeter we're going to look at in just a little bit. Let's see, after adjustment, we do have user manager, which is sort of where we can see all of the current users of the system. I won't go into too much detail on this, as this is something you'll probably be doing with Lou or with whoever else is using this. You'll probably be creating your functions like this, or we may have generalized users as needed. Setup, that's just your general setup information in regards to what we're going to be doing. So pretty easy. If you really wanted to change the color layout, I think Lou and I agreed on the Anton-Paar colors being a little bit better. So there's blue and gray. That one's not too bad. Black's a little bit vicious. And then blue is a little bit older. So we think we both agreed we liked Anton-Paar better, but if you guys wanted to have some fun, you can change colors on there. Oops. Oops, I keep doing that, sorry. So I have these refractive index and set temperature options. I wouldn't worry about these things too much. We have here, as I mentioned earlier, the instrument is connected via an RS-232 cable to the unit. So if anything gets moved ever or something gets unplugged and there is any issues with reconnecting back to the instrument from the PC, I would come here and check your COM ports. We do have the entire original installation files and driver files still on the PC here. So if those ever needed to be reinstalled or anything, they're right there for you. I'm not deleting them or hiding them in any way, so I wanted to make sure that if needed. And of course, if that ever happened and you had questions, please feel free to reach out to me as well. I'll leave my business cards down here. This is where, as I mentioned earlier, if you needed to print directly from somewhere in here, it already loaded the printers in this building. So if you wanted to just print something directly to one of your printers, you can do that there. Sample ID, as you saw on the screen here, you can add a sample ID. And if you wanted to add further fields of that, like a sample name as well as sample ID, you can add those here as well. Let's see. So to go forward, those are kind of just some of the settings we're interested in. Let me make sure I didn't miss any. I think the rest are pretty straightforward. So in regards to measuring, if you come down here and maybe the instrument hasn't been used in a couple of weeks or days or anything like that, and you wanted to just do so not a full 1 or 2 point adjustment, but just a general reference value, you can do that with either an air reference value or a water adjustment reference value. And so this water adjustment here, it's not as important as your 1 or 2 point adjustment. You can just use regular DI water for this one. And your air reference is something that you can use as well when you know you have a good clean cell, and I would close the lid on that and then hit your air reference. So I'm actually going to open my lid over here, take a look at it. I might actually put a little bit of ethanol on there, take my Kim wipe. I know you guys can't see me doing this right now, but you know, they can see. Oh, they can. Okay, great. Just kidding. And so then you can give it a minute to dry that cell. Make sure there's no more ethanol on there. Take a good visual inspection of it. If you see anything, any dust, sample residue, Kim wipe residues. And then you can come here to reference, and it will know for the most part about where your air is going to be. So actually, I see that my temperature is at 25 for some reason. On refractive index. Yeah. So I'm not going to set my air reference value just because my temperature is not at 20 where I want it to be. I think it would be totally fine if I did right now, but just in case, I don't want to mess up any thing in there to just do that. But however, I wanted to show you that that's air reference. It knows that it should be mostly air in there. So I'm going to grab a little bit of water here. This is just some DI water from this bottle in the lab. And so you can see the instrument began taking that reading right away. It's beginning to adjust the temperature. And if I go to reference, it'll know that I have water in there. So this is where you probably come in and hit water adjustment. So those are two things that I would recommend doing at the beginning of a day, and then proceed with measuring your actual sample. So of course, before you load your own sample, those two steps are good to do anyway, because then you can ensure that you have a good clean cell, everything's measuring properly, and then you can wipe it off and go from there. So for the most part, that's the majority of what we need to talk about. So I think from here on out, if there's any questions, it's a great time to see if we have any questions. Please feel free to type your questions in the chat or to take yourself off of mute and ask them. Let's see, we have a question coming, I believe.
No. Oh, yeah. This is set
The set temperature here, let's see. So it looks like I accidentally turned off my temperature control. So yes, it is now at 20. So you can see that I just did that there. So the question was, if anybody, for future watchers of this, what is the set temperature 20C question mark? So yes, I actually had accidentally turned off temperature control. So I had just reestablished it there, and now the instrument, you can see the set value and then the actual there. Okay, any other questions? I think that's it for questions right now then. So I guess we're going to go ahead and move forward to the MCP, which is our polarimeter. So I'll let Lou transition us there.
organic HD. Oopsie. Where's my menu? No, Untitled. No, okay. This
Minimum volume we can use to measure. Oh, I put it on. The minimum volume, let me double check if we have listed that. So to answer that volume question, approximately about 1 milliliter is the needed amount of volume for measurement. That does depend on the consistency as well as the viscosity of the sample, it seems, but for the most part, 1 milliliter or even less really would be enough to measure. So pretty much just to fill the bottom of that prism, which is probably only maybe a little bit less than a centimeter wide, I would say. So not much more than that.
I think yesterday also showed me that it has an automatically sensor
Yes.
to tell you if
Yes.
the volume is too low or something
Yep.
like that.
Exactly.
So,
If it's a little bit too low, it will tell you, hey, I would like a little bit more sample in there. You would see that pop up right underneath. Let's see, I don't think we're still on here, but right underneath
I can move it here.
Yeah,
You
it
can
would
move
say
it here.
not enough volume.
Yeah. Okay. So.
Yeah, you're welcome. Okay, so this is the MCP 5500. This is a polarimeter. This is the highest end polarimeter that we have. It's a pretty wide unit. We have the LED bulb is down here on this end of the instrument, and then we have the light shooting through here, and then the receivers are on this side of the instrument. Inside of here is the sample cell. I'll let Lou. Lou is a fantastic camera person, so
Thank you.
inside of here we have our sample chamber. This entire metal piece is all Peltier control. So that is a solid piece of aluminum that we get sculpted in our manufacturing facility in Germany at Anton-Paar Optotech. So we want to have as best temperature control as possible with this unit. This here, that little square bit, that is an RFID reader. So each of our sample cell and our quartz control plate, which I'll talk a little bit more about in a second, which we are trying to get here in time for this training today, but unfortunately did not make it. They are stuck at a carrier facility right now. Those cells on the bottom of them have a RFID chip here, and the information of that cell or quartz control plate is stored entirely on that chip. So, for example, if you have a quartz control plate and its certificate, you do not need to enter those into the instrument because that information for that quartz plate, all of the certificate information for different wavelengths and different temperatures is listed on that chip already. So the instrument will automatically read that, as well as the serial number, set pass length, everything like that, so that you don't have to input any of it. In the same regards to the sample cell, your pass length is written there. It knows exactly the diameter, exactly the pass length for that specific cell, including its serial number and any other very specific information. So that's just a really easy way to move forward with that.
Show a picture of this.
Yeah, so here, actually, Mark has pulled up a picture of our quartz control plate here. It's just a kind of a digital picture. So here is that tool master device, if that is what we call it. The RFID chip we call a tool master. That is a quartz control plate. So inside of that would be just a little sliver of quartz, which has a very specific optical rotation, which is saved on there. And we use that quartz control plate as a check medium as well as an adjustment medium for daily use. And that's just what you hold it with. Okay, thanks, Mark. So for the most part, I think we can go ahead and look at the menu as well as general use and talk about daily measuring with this guy. So this is the main screen we have, and this is your sample chamber, and then on the side here we also have an air pump connection. So this is just a little, let me see if you guys can see, I'll put it right here. This is just a silicon tubing hose with a lure adapter, and that can fit into your sample cell in order for drying. And you would just turn that on via that. And I'll go through each of our features here in just a moment. But I wanted to point out that we do have an air pump. So here is the general menu structure of the MCP. This is your home screen. So up here on our red toolbar, we can see our current method. If we have listed a sample name, that will be displayed there. This is where we can change users if needed, if you're going to be adding users to this instrument. And of course, your time, your current user. And this here, this chain link with limbs, we are actually connected up to our PC here. So all of the information that we are going to be transferring over, or excuse me, all the information that we are going to be taking in and measuring will automatically transfer over to the PC next to it in a digital form, so that that will be easily available. So the information will be saved here on the instrument as well as on the PC next to it. So to continue down, I'm going to go this right here. This gray box is our favorites bar. So right now we have our warnings and checks and errors. This is where that will be displayed if any of those pop up. Right here we have our filling check camera. So that is a live camera of our cell. So you can see that I'm actually messing with it there. So in regards to the sample cell, it is essentially a cell with a clear path with two lenses on the ends. And you can see through it when you take it out and hold it up, or you can even place it into here and the instrument will see through it for that light beam. In regards to filling, you can fill either out externally from the instrument, just in your hands, or you can fill internally with the instrument here, and then that way you can actually see yourself fill and make sure that you don't have any bubbles or anything. I was explaining to Lou yesterday, you do want to make sure to have as few bubbles as possible in regards to this circle. However, if you have a sample that's very difficult, say it's very viscous or oil-based or something like that, if you have a bubble that reaches about here and you really can't get it out or anything like that, as long as this center view is not clouded up and there's no bubbles blocking it, as long as there's nothing coming down about 50 or 40%, you should be able to still get a very accurate reading as long as the instrument can see through there. So it's nothing to really worry about. Personally, I often fill my sample cell externally, and I often use 2 syringes. So the sample cell has 2 Luer inputs on the top of it. Excuse me. So I often use a empty syringe on one end and a filled syringe with my sample on the other. And then I will often hold the cell. Let's see, I'll use this. So I will often hold the cell at a slight angle like this, where my closed and empty syringe is just fitting here, and my syringe filled with sample is here, and then I will slowly push samples through. And the reason for this angle is so that if I have any bubbles, they will be encouraged to float to the top here and go out into that empty syringe. And so then I'll continue to fill, and then as I do that, I can also hold the sample cell up and look through as well. So here, actually, Mark has a picture as well. So as I was mentioning, I often use syringes to do this, but you can also fill here. So let's see, I'm going to get you closer. So you can see that this person here has a syringe with their sample, and there is a silicone tubing, which is not necessarily needed, but you can use. You can also take that syringe. The syringe fitting will fit in properly right into that port as well, so you don't have to have this hose. And it's going to flow through the cell and then come out this way. So they have that going to a waste beaker. That is a totally acceptable and usable way to fill the sample cell. Everyone kind of has their different preferences for how they best do it. I prefer to use 2 syringes in case, because I can kind of go back and forth and troggle the syringe needed if I continue to have bubbles for whatever reason. And some people prefer to fill inside of the measurement chamber. And that would be helpful, especially if you have a sample that's maybe a little bit more dangerous and you don't want to be playing with it and using it externally too much. So that kind of depends really on what you're measuring and your personal preference as well. So again, I think we have the filling check screen here, and so that's that live reading, and you can always save a picture right here. And as you measure, when the measurement is saved, a picture of the cell currently at the moment of measuring will be saved as well along with it. So you have the option of saving it manually, but then you can also tell it to save it with every measurement you have. The camera for the filling check will actually slide into place in front of where the optics are and snap that picture, and then it'll move back out of the way. Okay, so that was our filling check. Here we have to just turn on and off our air pump, which is here. And I will get into cleaning in just a moment, so I'll come back to talking about the air pump. And then this button here is for zeroing out our cell. So to go into that just briefly, and I might go into it again in a moment, when you are preparing a measurement, one of the things you want to do is make sure that your solvent or whatever your medium is going to be for dissolving your sample, or whatever your sample may be, if it's already liquid, this may not apply to you at that moment, but you want to tell the instrument that, hey, the sample cell that I have in here, as it currently is optically inactive. So that zeroing out, you would most likely do it with your solvent, whether that's water or something like that. You would place your cell, you would fill the cell with the solvent, place it in here, close the lid, hit 0. The instrument will zero itself out, and then you can take out the cell, possibly clean it or continue to fill, and then go ahead and load your actual sample in. So essentially, you're just loading your wayboat into your balance and hitting tar. That's sort of what that is right there. If you wanted to have other favorites buttons, they can be placed here. Right now, we just have our monitor mode, which is currently grayed out. The measurement will be frozen on the screen after it has finished measuring, and then if you want to go back to a live reading, you can hit monitor mode. You can also have several pages of favorites as needed. To save something to your favorites bar, I'll go through it really quickly. You can go to wherever you want to be, wherever that may be. Say I want my check result data to be on my favorites bar. When you see this button at the top of your screen, this little menu with an arrow, you can hit it, and that will say, do you want to save this window to your favorites? You can say OK, and then we'll go back to our home screen, and then we can see that check result data is right there, and I can hit it, and now that's where we are. So to continue with our home screen, down here we have our general menu button, which we'll go through in a moment. There's also a quick button to get to our measured data. Quick settings, which is mainly just entering in your sample name, or if for some reason you are looking to calculate your concentration values or your SR values per a sample. Say you're trying to figure out what your specific rotation is for something. The instrument will measure optical rotation. You would then tell it what the concentration is of your sample, and then the instrument will then calculate your specific rotation from there. You can also change the temperature for the next measurement, and similarly to how the ABBEMAT multi-wave had the ability to toggle on and off, whether you have temperature control, the MCP can do that as well. And it seems kind of silly, but there are certain standards out there that do ask for that. So that's why we have it available. So to put your sample name in there, you would just click that, and then you could just type it there. Let's see. Next is method. So this button here for method, this is not to edit your method, it is just to select which method you're going to currently be using. So say I wanted to measure a specific rotation, I can toggle it there. And then, like I mentioned earlier, I can come into quick settings, and that's where I can enter in my concentration value if I was looking to calculate specific rotation.
How can I know what is my current method?
Your current method will be displayed right here at the top of the screen.
I see.
If you guys didn't hear that, Lou asked how we know what our current method is, and it's just displayed right there. So from there, I think I'm going to go forward and talk a little bit more about what's inside of our menu structure here. So say you've come into your lab, you've begun your day, and you're ready to run measurements on the polarimeter. The first thing I would recommend doing is taking a quartz check. So as I mentioned previously, our quartz control plate, or QCP, has a thin sliver of quartz with a very specific and standardized optical rotation. The quartz control plate that we have coming for you today is at 17 OR, and that is again loaded on the quartz control plate. So what you would do, you would just come in here. Oh, and again, this is just a normal check as you would do maybe a water reference or something of that type. So we would come in here, go to checks and adjustments, check management and execution. And then once we load our quartz control plate, as I mentioned, the instrument will know that it's in there and will take its values. And so then you have the ability to select that quartz cell and then hit start right here. And then the instrument will just walk you through that. It will actually have you initially put the cell in, then take it out to zero itself out, and then it will instruct you to put the cell back in, and then the check will run through automatically. And then that's it. It takes just a couple of moments. It's not a very long process, but it's something to just make sure to do, especially if the instrument hasn't been used in several weeks or months, which is fairly common. So after your quartz control plate check is done, you can therefore go ahead and measure your samples. So let's talk a little bit about the sort of measurements we have. And I mentioned this previously, referring to specific rotation and things like that. So let's look a little bit further at the current methods we have available. So the main one, of course, is what the instrument is mainly measuring, which is optical rotation. So there are standardized methods here already. So often if I want to edit a method further, I usually leave it alone and I copy it. So if I hold down that method, it'll give me the options to copy, delete, or rename. Since this one is a standard method with the instrument, it's not allowing me to rename it, but I will go ahead and copy it. So once it's copied, it'll ask me what I want to name it, and I'll just leave it number 2 right now. And I'll scroll down. So here it is, here, the one that I just copied. So I'll select it. So just hitting it one time will bring me to where I can edit that method. And again, if I hold it down, that's when I get those options. But say I just want to edit it, so I'm just going to hit it one time. So we have several different measurement modes with the polarimeter. There's, of course, just standard, which is when you place the cell in here with your sample, you hit start, it takes one reading, and that's it. With multiple measurement, you can tell that is very helpful if you're doing repeatability studies with the same sample. So you could hit multiple measurement, and it will then ask you how many measurements you would like it to take, and if you want to average them and such, and you can use that. This instrument does have 2 wavelengths. It is 589, and I think 1 in the 300ths as well. So this one does have more than 1 wavelength, and I'll show you specifically what those are in a moment. You can do a multi-wavelength scan with a sample as needed. There's also multiple filling, which is fairly straightforward. You can tell the instrument that you want to fill multiple times, and it will take a measurement, instruct you to fill, take a measurement, then instruct you to fill as you have told it to do. A time scan is something that if you have a sample, for instance, that may degrade over time and you want to watch how the optical rotation changes for that, you can set up a time scan and tell it, I want to measure it for 20 minutes or half an hour, and I want you to take this many measurements and tell me what my optical rotation was at each of those points. So that's very helpful. The same way with a temperature scan, you can say I want to start from 5 degrees Celsius and go up to 50 degrees Celsius, and I want you to take a measurement evenly throughout that point. And then a temperature table scan is the same concept, only you will tell it specifically at which temperature points you would like it to take that measurement. Any questions on those right now, or any questions up to this point? Looks like we don't at the moment, so I'm going to keep going. So again, that was just, so we're back to our method and just editing what that method can be. So we were in measurement mode. And I'll go down just a moment. The majority of this is not things that will be used commonly, but I will get to MCP module in just a moment, so I'm going to skip that one. If you wanted to have a method that had mandatory fields, specifically sample name, if you wanted to make that mandatory, you could do that right there. So that way, when you start a measurement, it'll pop up like, hey, you have to name this sample. Formula perimeters, if you needed to use any of these for a specific sample, likely you would know if you need to use them. I won't go into detail right now about those. We do have more instruction on those in our reference guide. These are often used in a pharmaceutical setting where we're looking at very, very accurate information about measuring concentration and stuff via OR. If you wanted to change what your main menu looks like for that specific sample, you can change the layout type for your main menu. The widgets on the main menu are able to be edited as well, and this is just part of that. So I'm going to leave it as it is right now. Result output, which is different than display layout and layout type. Result output is what will actually be written in the document that is being exported by the instrument, specifically to your PC here. So we have just master condition, date, time, method, sample name, OR, etc. And if you would like to add more, you can come here, select this box, select a group. For example, you could say what the cell serial number is on there, and then that will be on that. So, and you can move them up and down as needed. If you wanted to add limits to a measurement, that will warn you if your measurement is outside of the set limits. And then your quick settings measurement, if you wanted to add a specific note to what is in your quick settings menu screen on your front page, you can do that per method. So I'm going to go back now to MCP module, which is our second editing button here. So I'm going to go back to that because that's a little bit more important and I wanted to focus on that one. So we have the ability here to just change the basic settings of that.
Is it locked up?
No, you are right.
Oh, okay. We were having a little bit of an issue, but I think everything's okay. So our method type. Okay, good. So as I mentioned, delivered scales, that'll be just mainly your optical rotation and any tables or anything like that you may have needed that are based on optical rotation. But if you wanted to change that specific method to either calculating SR from concentration or calculating concentration from SR and measuring OR for both of those, you can change that there. You can also change the accuracy level. Accuracy is completely based on temperature stability. So if you have something that you would like it to be a little bit less accurate but will go much faster, you can hit that fast measuring button. The differences between those will probably only be by a couple of minutes. It usually isn't too much of a big difference between those levels, except for if you have like fastest measuring, it may not wait for your temperature to stabilize all the way to, for example, 20.00. It may stop at like 20.3 or under, and then it will stabilize out, or then it will stop there, whereas most precise will wait until it's right at 20.00 and stabilize there. We also do have a timeout button that if the OR is not able to stabilize or the temperature is not able to stabilize within that time period, it will then time out and the measurement will stop. You can also select this button if you want to protect this method from other people editing it. This one is very important, your nominal cell lengths, as this is what your pass length is and that is the physical length of the sample cell that you have placed in your measurement, your sample in, excuse me. So I'll kind of bring you up here briefly. The entire length of this sample tube is 200 millimeters. So that is the longest that we can go, and we do have cells available for that. The one that is coming, that was supposed to be here today, is 100 millimeters long. And so I will likely place some of your methods to 100 millimeters so that that is calculated correctly. And the instrument will know what length of cell it is that is placed in here. However, you may need to change your method to a 100 if you have not edited that already, since methods and their calculations are based off of that. So the instrument will know if you don't have 100 mil in there, or excuse me, a 200 mil if that's what you've edited your method as. So it'll just warn you about that as you go. So that's probably it there. Your wavelengths, again, you can change that per method. So you guys have 589 and 325 available. You can change that per method. Integration time, I believe that is, don't remember off the top of my head, but I believe that if you wanted to allow, once you hit start, if you want to give it a couple of seconds until it actually takes the reading, after temperature has stabilized, you can add that there. Again, if you wanted to set a specific temperature to not be controlled, you can do that there. And then you can also set the temperature for that method here as well to be a permanent temperature. You can always change your temperature for your next sample on the main screen, but if you wanted it to be a permanent change to that method, that's where you do it. And then these last ones are kind of obvious. Max temperature deviation and hold time. Do we have any questions in regards to measuring, to method editing and things like that? That was quite a lot of information. I kind of threw at you all at once there, so please feel free to write any questions you have into the chat box. Let's see. It looks like we don't have any.
No, question pop up.
Okay, so I'm gonna move forward then. So I'm just gonna go back. Let's see. I'm gonna go up here again. So say that we're back to the beginning of the day of measuring. We haven't run any samples yet. We've just run our quartz check. And say that our quartz check has failed for some reason, which does happen sometimes after moving the instrument around, after transport or something like that. We may need to run an adjustment with the quartz. So if your quartz check has failed, I would then advise you to come here to Polarimeter adjustments and then to perform a quartz adjustment. And it'll be the same procedure as with your check, where you take the quartz out of the cell, let it zero itself, and put it back in, and then the adjustment will run. You can also choose which wavelengths you would like to adjust. And then once you do that adjustment, you're good to go. The entire measuring mechanism and filters of the polarimeter are essentially one circle. If as you know, with how polarimetry is measured, we do have to. I kind of do this most of the time. So if we're polarized, we can see light fully, and then if we close that up, we can't see any light coming through. So since it's just one circle, it's easy to adjust at just one point. So if we get that one point correctly lined up, then we're good to go from there. So that's why we're able to adjust using just the quartz control plate. And that is certified by a third party as well. So that's not just something that we're just putting in there and assuming it is accurate. That is calibrated thoroughly for multiple wavelengths and multiple temperatures. Let me see, what else is there? I think it's probably time to talk about data transfer. So I think, Lou, I'll have you come back over here. Oh, yep, okay. Lou is going to log us in to the PC next to the instrument. Let's see, I'll lose a better camera person than I am. So we're using a software, which is just a data transport software called LIMSBridge. So you can see that this icon here is LIMSBridge. I'm actually going to ignore that one. And you'll see right here on this tab, or you can kind of see it, there's a little LB that's red that has a little green check mark on it. And what that means is that we are correctly, automatically connected and communicating to the MCP from this PC. So that's great. So it's already on. I don't need to actually do anything. So what does LIMSBridge mean? It's not a database, and it's also not something that you can pull up necessarily and look at all your data from there. But what it's doing is allowing a port to open between the instrument and the PC in order for the instrument to essentially just pull the data from itself and place it onto the PC as well. So we have this file right here, and I'll open that up. And you can see that we have the adjustment data, check data, and measurement data. And we have assigned each of those forms of data to be exported directly to these files. So it will still be on the instrument, but it will also be available here on the PC as well. Our measurement data is going to be coming over as an Excel file, but our check and adjustment data will be exported over as a PDF. And that is fairly easy to change as needed. I will briefly show you how to edit this. However, it's something that we probably would suggest not very many people poking at, because if it's set correctly, we don't really want to change anything in the meantime. So, but what I'm going to do is this little LB here down in our taskbar. Oh, I know. I keep changing where Lou is. And I'm going to right-click and then go to Configure. So we can see here that there's our MCP, and that little asterisk means that we are properly connected. In order to edit that, I'm going to actually disconnect from the instrument and then go to Edit. And then this window pulls up, and you can see that I can come in here and change my measurement settings, check data settings, and where that's going to be exporting to, and then the file type as well. I can save that. I can come back over here, select my instrument, hit connect, and we're back, we're connected again. So unfortunately, since we don't have a sample cell, we haven't been able to, we wanted to be able to show you guys how quickly that measurement data is able to transfer over. It's completely automatic. You don't have to touch anything as long as they are properly connected. It'll just come right over on its own, all of these types of data, so you don't have to worry about exporting anything. It'll do it automatically. Yeah, and I think for the most part, that is the majority of what I was going to cover today on this instrument. So overall, does anybody have any questions on either setup, either the ABBEMAT multi-wave or the Polarimeter? Please feel free to reach out now. Feel free to type it into the chat window or to unmute yourself and ask as well.
Okay, any questions?
Okay, I
please?
guess.
No? Yeah. Yeah.
Okay, we have, looks like
Oh,
Dr.
sorry.
Torsten
Yeah.
is typing. How many sample cells between min and max are available? Is that referring to sample volume or just path length? The sample volume for the one that is coming, I believe, is about 2 milliliters of sample volume, and that one's a 100 millimeter. I believe we also have sample cells available that are between 10 millimeters pass length up to 200 millimeters. So you can go anywhere in between that. The sample size will also depend. Sometimes you have a 100 millimeter that may only have a sample volume of about 0.5 milliliter, and that is because the internal diameter is smaller. And so that we can, I believe it's 100 millimeter, 10 millimeters, 50 millimeters, 100 millimeters, and 200. Those are the averages, and I believe we do have ones in between there.
So yeah, I just saw on the website that it says volumes from 0.7 to 4 milliliter.
Yes.
And so it gives me the minimum and the maximum. I was wondering how many in between.
In between. I believe the one that you will have is 2 milliliter. I'll have to double check that with the part number, but that should be the one you have. Here we go. Yep, 2 milliliter is the one that's coming. And then we have a lot more available. We actually have this booklet here that has all of the ones available. So we have ones that have funnels even, ones that you would fill with just this. This is specifically the one you have will be this one that's coming. This one is stainless steel. We also have ones that are Hastelloy available that are a nickel alloy, which are a little bit more resistant to different sample types. Here's one of the ones that is 50 millimeters.
Okay, thank you.
Yes, yes.
Sounds good.
Great.
Well,
Any other questions, guys? Feel free. So again, like I mentioned, the cell that is coming that we've gotten for you is stainless steel. So I would double check any samples you have that will be compatible and that there won't be anything. I don't want any interference with your measurements to occur with that. Unfortunately, we were hoping to get you a Hastelloy one, but the only one we had available at the moment was stainless steel to get here as quickly as possible, but we do have others available.
If anybody asks about it. If anybody asks about it, I got that.
Yeah, Mark actually, here Mark, I'll show them. This is actually the internal structure. I don't know if we're able to see it properly.
I'm gonna tilt it a little bit.
Yeah, it's a bit hard. We might have to send that at a later time, but this is what you have internally in the polarimeter. So you have your light beam here. Wait, where am I? Backwards. You have your light beam here, and then here's your polarizers, your Faraday modulator, your actual sample cell. So this is where your sample cell is located. I'm looking at it upside down. But, your analyzer, and then our photo receiver there. So that's actually what we have internally on the polarimeter, which is interesting to see. Thanks, Mark.
Yep.
yeah. So,
Any other questions, you guys? Looks like we don't.
okay, yeah, then.
Lou, do you have any questions?
No, I'm good. My question is when myself will arrive.
Yeah, I know. I can actually.
Yeah.
Yeah, I'll
Yeah,
check
but
this
I really want, thank you and Mark for the visit, and thank you very much. And we may bother you later with more questions when we start again.
Yeah, please feel free. And again, I'm leaving my my business cards here with the instruments. I've got one on each. Yes, thank you. You're welcome. So I'm leaving these on the instruments so that they're there. So please feel free to call me or email me with any questions. Yeah, the sample cells will get here today. They're just unfortunately not here at this moment. So that
We'll
stinks.
check on it.
Yeah, we'll hopefully get those as soon as possible. But
Right.
thank you, everybody. We really enjoyed coming out here to Kent State. It's a nice day. So thank you. Have a good one. Bye.